Hello students, welcome to Shala.
First of all, I wish you a very happy New Year 2024 from Shala. God bless you all. Today we are going to study about covalent bonds from chapter 4, Carbon and its compounds.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel Shala. This gives us a lot of motivation to keep creating these kind of videos for you all.
What is a covalent bond? When a non-metal reacts with another non-metal, mutual sharing of electrons forms a bond. So students always remember, whenever we study covalent bond, it should come in your mind that we are talking about sharing of electrons. And when the sharing of electrons takes place, it should immediately come in your mind that we are talking about a non-metal and with a non-metal. Always remember, covalent bonding takes place between non-metal and a non-metal. Now, before starting with the examples of covalent bond, I would like to also share with you some tricks to remember about the bonding. Whenever students you see two electrons or one pair, it forms a single covalent bond. Whenever you see four electrons, that means towards sharing part. Whenever you see four electrons or two pair, that means it is forming a double covalent bond. Or whenever you see six electrons in the sharing part or three pair, that means we will be having triple covalent bond. So this is the bond formation shown over here. So these things, little things, you should keep it in mind while showing the covalent bonding, while showing the sharing of electrons. Always remember, atoms share their electrons to have noble gas configuration in their valence shell. And what is valence shell? The outermost shell. That is to complete their octet or duplet in case of hydrogen only. Now we will be also talking about the types of covalent bonds further. Now before this, I would like to also share that this sharing of electrons may be between two similar or dissimilar atoms. The bond formed by mutual sharing of electrons between the two atoms is called covalent bond. The compounds containing covalent bonds are also known as covalent compounds. So students, all these terms, whatever is coming while discussion, you should always keep it in mind. This is one of the very important thing, that you should keep it in your mind. Now, first of all, we will be talking about types of covalent bonds, which is also known as single covalent bond. Now, let us take an example of hydrogen molecule. Now, whenever I say hydrogen molecule, it means I'm talking about H2. Always remember, a single covalent bond is formed by mutual sharing of one electron pair between two atoms. In a single covalent bond, each atom contributes one electron for sharing. It is represented by a single line between the two atoms. Between the two atoms sharing electrons. Now, how do we show all this, whatever I have said just now? Now, in the right hand side corner, children, I have written, which I told you in the beginning, a little trick to remember to memorize about the sharing of electrons and which bonds will be formed. So please recall whatever I taught you in the beginning. Okay, now let us show the formation of hydrogen molecule, that is H2. How we should show it? Now that we are going to study one by one. So, atomic number of hydrogen is 1. So, what I do? I write down the atomic number 1 and the electronic configuration of hydrogen will be 1. So, we have written for hydrogen over here and for other hydrogen also I have written over here. This is all to make you understand how you will show the formation of hydrogen molecule. So I have written electronic configuration 1. I have written electronic configuration of other hydrogen also 1. Now this 1 which I am seeing over here, that is the valence shell only. Why I am saying valence shell? Because atomic number is 1 and only 1 and 1 shell is formed, which is known as K shell. And if an atomic number is 1, so if 1 shell is formed and the 1 shell is only the valence shell. And the electrons in the valence shell are known as valence electrons. Right, children? Okay. Now, after this, I have to see that what should I do to make this stable gas configuration. In the beginning, if you remember, I told you that the electrons, that is the atoms which share the electrons, they do it because they have to attain the stable gas configuration in their valence shell, that is to complete their octet. But over here, in the case of hydrogen, I told you that it is only and only hydrogen which shows the duplet state. But it also attains the stable configuration. That means by sharing its 1 electron by each hydrogen atoms and then forming the duplet, that means 2 electrons in sharing they will show, and what will happen? A single covalent bond will be formed as shown over here. So what this hydrogen will do? This hydrogen says, I have only 1 electron in my last shell, that is valence shell. So this hydrogen says, I want 1 more electron. If I get 1 more electron from anywhere, so what I can attain? A stable gas configuration of helium. But this electronic configuration of hydrogen is having only 1. So this hydrogen says that my other friend hydrogen is also having 1 electron. So what we should do? We should rather share it with each other, our 1 electron. So this hydrogen says, okay, friend hydrogen, I am sharing my 1 electron over here. So this hydrogen says, okay, I will also help you, and rather helping you will be my help also. So this hydrogen is also sharing 1 electron with this hydrogen. So they have shown the sharing over here. This hydrogen has shared its 1 electron. This hydrogen has also shared its 1 electron. After sharing, they form a duplet, which is helium. That is the stable gas configuration they have attained. So, after sharing, this hydrogen, if we see, it is having 2 electrons. If we see this hydrogen, it is also having 2 electrons. So, by mutual sharing, they have attained their stable gas configuration, that is the duplet state, and hence forming helium, that is the stable gas configuration. So after they form the stable gas configuration, they are very, very happy. So what they do? They say, okay, we have shared the electrons, and in the beginning, children, I told you that if it is 1 pair or 2 electrons, it will form single covalent bond. So what they do? They show the single bond over here because they have 2 electrons or 1 pair in this sharing part. So they show hydrogen, single bond, hydrogen. So this is known as single covalent bond. And in this way, we have shown the formation of hydrogen molecule. So this is the first example of covalent bonding, which says single covalent bond. Okay, we will go to the next one. So this is the formation of oxygen molecule. Now, oxygen molecule, if I say, I mean to say this is O2. Right, children? So that means I'm talking about O2 molecule. That is, we are going to study about double covalent bond. A double covalent bond is formed by mutual sharing of two electron pairs between two atoms. In a double covalent bond, each atom contributes two electrons for sharing. It is represented by double bond between the two atoms sharing electrons. So, how we are going to show the formation, children? We are going to show the formation by writing the atomic number first. Atomic number of oxygen is 8. I will write the electronic configuration. I've written EC, that is 2 and 6, right? And this is K shell and this is L shell. Now we have to work on the last shell, that is the valence electrons. I've written also other atom electronic configuration as well over here, 26Kl. We have to work on the outermost electrons, that is the valence electrons. Now this oxygen says, what should I do so that I attain the stable gas configuration? This oxygen says, if I get two electrons from somewhere, so I can attain the stable gas configuration. That means I will attain the octet state. Of course, this oxygen was also thinking the same way. So two electrons I want from somewhere. So this oxygen says, I will share my two electrons then. So that means, children, always keep it in mind that if this oxygen shares two electrons, that means oxygen will share two electrons from its outermost shell only. If this oxygen shares two electrons from its outermost shell, that means out of 6, 2 electrons oxygen will share, and how many will be left? 4. So this oxygen, I write it over here, and this oxygen has shared its 2 electrons over here. Yes, this cross one, beta, you take it. This oxygen, I have taken it with cross, and this oxygen I have taken with dot. Just to, differentiate between the, you can say, electrons, so that you do not get confused in the beginning. That is why we have taken this cross for this oxygen and this dot for this oxygen, so that you do not get confused. If you are okay with this, you can take all the electrons in dot or all the electrons in cross. But I am teaching you so that in the beginning, when you are in the learning stage, you do not get confused and you do not commit any mistake. That is why I have taken like this. And in many, many books, it will be like this also, or it can also be shown with the help of all dots or all crosses. So do not get confused. Okay, children? Okay. After this, what I was saying, that this oxygen says, I will share my 2 electrons over here, shared. And after sharing 2 electrons, after sharing out of 6, 2 electrons shared, and how many left? 4. So they have shown 4 over here. Other oxygen says, if you are doing, I will also do it, and we both will be benefited. So this oxygen says, I will also share my 2 electrons, shared, and out of 6, 2 shared, and how many left? 4. So this is shown over here, 4. After sharing, both the oxygen atoms were very, very happy that after sharing, that is, sharing is caring, so they cared for each other, and after sharing, they attained the stable gas configuration, that is the octet state. Now you check over here. If we see this oxygen, it will be having 8 electrons. See, 1, 2, 3, 4, 5, 6, 7, 8. They were very happy. Okay, 8 electrons, I got it. This oxygen said, let me check also. 1, 2, 3, 4, 5, 6, 7, 8. This said, oh, I'm also very happy. So both are happy. When they were happy, then they came to the conclusion that after sharing, we both have attained the stable gas configuration. Now let us check our mutual sharing. That means the bond formation also we have to show it. So they say that I have 4 electrons in my sharing part. Both the oxygen atoms said that we have 4 electrons in our sharing part. So oxygen said that if we have 4 electrons or 2 pairs, that means we will be having double covalent bond. So they said, yes, now the time has come to show the bond formation. So oxygen, double bond and oxygen. So this is known as double covalent bond. And in this way, they have shown the formation of this double covalent bond by mutual sharing of the electrons. So they have attained the stable gas configuration, that is octet state. So this is an example of double covalent bond. Now the next comes triple covalent bond. The same thing, children. Okay, we are taking the example of formation of nitrogen molecule. Again, nitrogen molecule means N2. Right, children? So this you have to remember. Okay, triple covalent bond. A triple covalent bond is formed by mutual sharing of 3 electron pairs between 2 atoms. In a triple covalent bond, each atom contributes 3 electrons for sharing. 3 electrons for sharing. It is represented by triple line between the 2 atoms sharing electrons. Now, for example, we have taken the example of nitrogen molecule. Now, nitrogen contains 5 electrons in its valence shell, as you are seeing it over here. And it acquires 3 electrons. It requires how many electrons? 3 electrons to acquire what? Stable gas configuration, nearest noble gas configuration. That is to complete its octet. It may complete its octet by sharing 3 electrons with other nitrogen atom, forming a triple bond. So the formation of nitrogen molecule is shown over here, children. Now what we will do, again the same thing. Again the same thing you have to follow. We will write nitrogen, nitrogen. Atomic number is 7. Electronic configuration is 2, 5. 5 is the valence shell. Valence electron, we have to work on it. Again, here also we have to work on the valence electrons. So, nitrogen says that this 5 electrons I have in the outermost shell. So, I need 3 electrons to attain the stable gas configuration. So, this nitrogen says that out of these 5 electrons, that is the valence electrons which I have, I will share 3 electrons from here and I can attain the stable gas configuration if other nitrogen atom also accepts and says I will also do the same thing. Other nitrogen also says, okay, I will also share it. What's a big deal? So, this nitrogen shares 3 electrons from its outermost valence electron. If it shares 3 electrons from its outermost valence electron, so how many are left? 2 over here. So, nitrogen shares 3 electrons and 2 are left. So, it places its electron over here 2 and 3 over here. Other nitrogen says, I will also share it. So, other nitrogen also shares 3 electrons and leaves 2 electrons over here. Okay. Now, again, the same trick which we will follow, which we are following from the beginning. If there are 6 electrons or 3 pair, it will form a triple covalent bond. So, I will show it over here. Nitrogen, triple lines and nitrogen. So, triple covalent bond formation is shown also over here. So, this is also done, the third example of triple covalent bond. So, I've told you everything in detail, children. Always remember that the sharing is going on to attain the stable gas configuration. Always remember, children, whenever we do the sharing part, that means our motive is only to attain the stable gas configuration. Always remember, this is our motive for doing it. So, in the case of only hydrogen, we will have the duplet. Again, I repeat, we will have the duplet in the case of hydrogen only because it is always having atomic number 1. That is why duplet is always in the case of hydrogen. And others will have the octet, that means the stable gas configuration also again it will form. So, again, repeat this, children, whatever I have taught you in today's session. Please go through it. In your exam, this kind of formations do come. I will be taking some more other examples also of this single covalent bond, double covalent bond and triple covalent bond. More examples in the next video. Till then, keep on revising this because I've taught you in very, very detailed thing. Very, very minutely I've taught you. This is the main root of this topic that you should know how the bond formation will take place with the number of electrons or pair. Again, I repeat once again, 2 electrons, 1 pair, single covalent bond. 4 electrons, 2 pair, double covalent bond. 6 electrons, 3 pair, that is triple covalent bond. So that's all for today, students. Take care and keep on revising again and again. Once again, God bless you all and wish you a very, very happy new year. May God give you tons and tons of happiness throughout and succeed in your life always. God bless. Bye-bye.